we are going to solve equations of the form sine n theta plus alpha equals to k. Look at this example. Solve the equation sine 2 theta minus 35 degrees equals to minus 1, where the interval of theta is between minus 180 and 180. Also here we substitute the angle by x. Let x equal to 2 theta minus 35 degrees. We are solving equation in the form of sine x equals to minus 1, where the interval for x will change. Theta is between minus 180 and 180 degrees. 2 theta will be between minus 360 degrees and 360 degrees. So we simply multiplied by 2 for the whole inequality. Now we need to subtract the 35 from the whole inequality. So we will have minus 395 degrees less than 2 theta minus 35 degrees less than 325 degrees. So the range for x is between minus 395 degrees and 325 degrees. This is the range for the new angle. Now we will solve for the equation in the form of sine x equals minus 1. To solve this equation, we rely on this graph for the sine. Here the range is between minus 395 and 325. But we do not care about continuing after the minus 360 because it won't reach minus 1. Inside this range, we take the sine to be equal to minus 1 and we check which angles produce this value. The angles are minus 90 and 270 degrees. So, x is equal to minus 90 degrees or x is equal to 270 degrees. These are the values of x that satisfy the equation sine x equals minus 1. The values of x are found in the interval that we specified. Now we need to go back to theta since x equals 2 theta minus 35. So 2 theta equals x plus 35. Therefore theta is x plus 35 over 2. Below we say the following. Theta equals x, which is minus 90, plus 35 over 2. The answer is minus 27.5 degrees. Now here, theta equals x, which is 270, plus 35 over 2. The answer is 152.5 degrees. As you can see, these two angles are inside the range that is specified for theta. Pay attention that when we have sine or cosine equals to minus 1, 0 or 1, then we use this graph within this range because it is a special case. Then you define the angles corresponding to it and you go back to the initial angle given, which is the theta, in order to calculate the exact value for it. You can solve exercise 1 in the same way. It is a mix between this tutorial and the previous one. In A and B, you will rely on the graph because sine and cosine are equal to 0 and minus 1 respectively. However, in other parts of exercise 1, you will use the quadrant plane.